Hello everyone. Today let's solve the Leetcode problem number 1 to 4. So binary tree maximum path sum. So what the question says, a path in a binary tree is the sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them, right? So a node can only appear in the sequence at most once. So this is important. A node can only appear in the sequence at most once. So note that the path does not need to pass through the root. The path sum of a path is the sum of the nodes value in the path. This is fine. And given the root of the binary tree, return the maximum path sum of any non-empty path they have asked. So again I'm telling, given the root of the binary tree, return the maximum path sum of any non-empty path they have asked. So initially they have took this example. So one is, and they have given 1, 2 and 3 we have got. So the path they have given is the highest value that we get is from the value 2, 1 and 3. The path 2, 1 and 3, nothing but 2, 3, 3 plus 3 is 6. That's what they have given here, 3. So I'll just take this example. So I'll just show what can be done. So just give me a second. So let me consider this example itself. So I'll just take here a root node. Initially they have given us 1, 2 and 3, right? So initially what we can do, we will just traverse through the root node, from the root node to the left subtree, and also from the root node to the right subtree. So we get the value, node values 1, 2 and 3, right? So the next step what we can do is, here we can get the max of root node and the left this one node, the left child, right? This one plus this one, root plus root node initially 1 and 1 plus 2 left subtree, nothing but the root value, the value of the root node and the value of the left subtree, this one, and finally the value of the root node and the value of the right subtree, nothing but 1 plus 3. We will be considering max among these numbers. So it will be 1, 3 and 4, right? Max of 1, 3 and 4 will be this one, 4 itself, right? So I'll just delete this one. So I'll just consider 4 now. After this, what we will do, we will find the max of this one, maximum, as well as max of the path. So root node, the left subtree as well as the right subtree. The value of the root node, the left subtree as well as the right subtree, nothing but 1, 2 and 3 here. 1 plus 2 plus 3 is 6. Max of 4 and 6 we get as 6, right? So here in the output also we have got the same 6. So this is so let's continue by writing the code. I'll just delete this one. Initially what I'll do, just give me a second. Initially what I'll do, I'll just initialize the result variable to negative infinity to handle the cases, right? And just give let result equals minus infinity. This is one thing. Next what I'll do, let's consider the helper function to traverse the tree and calculate the maximum path sum. That's what I have said, right? We will traverse through the left subtree as well as we will traverse through the right subtree. So I'll just make use of the helper function for this. Let me give function traverse. Just pass the parameter node here. So first, what is the base case? If the node is null, we will return 0. So suppose we don't have any value in the node. Initially, we will just return 0 in that case, right? We cannot build that. We cannot build that tree if we don't have any node. So we will be returning 0. That's the base case. So I'll just give if not of node, return 0. Next step, what we'll do, we'll recursively get the maximum path sum of the left subtree, nothing but 1 and 1 plus 2, this one. Next, we will get the right one, 1 and 1 plus 3. That's what I had showed you, right? So first, what we'll be doing, we'll be recursively getting the maximum path sum of the left subtree and right subtree. And just keep let left sum equals traverse. I would have just copied the function name. It's fine. Node dot left. I just copy this one. Yeah. Next, we have to recursively get the maximum path sum of the right subtree as well. For that one, I'll be doing right sum equals, copy the function name, node dot right. So after this, what we'll do, let's calculate the maximum sum for the current node, considering the current node's value, and also the possible inclusion of the left and right subtree path sums. So I had shown here, right, for you. We'll be considering the max of this one, root node, as well as the root node and the left subtree, and the root node and the right subtree, the max of this one, and then finally we'll be going with the max of maximum value that we have got, and the all the nodes, the sum of all the nodes combined together. That's what we'll be doing here. So I'll just give let max sum equals node dot value. So I'll just make use of mat dot max here. Sorry. Node dot val, node dot val plus left sum, node dot val plus right sum. So this is one thing. After this, what we will do, let's update the global result variable with the maximum path sum that has been so far. I had showed you, right? So maximum, the first step, the maximum that we got is 4, and then we will be comparing this one with the sum of all the nodes together. That is 2, 1, 2 and 3, or 2, 1 and 3. 2, 3, 3 plus 3 is 6. 4 and 6, max of 4 and 6 we got is 6, right? In the example. So that's what we'll be writing now. So and just give result equals, again I'll just make use of mat.max, the result max sum, and the example we got 4, and the node val plus left sum plus right sum. Right, nothing but the left and the right subtree values. So node dot val is nothing but this one, 1, 2 and 3 we are doing, right? So next, after this, we will just return the maximum that we got. So let me just return the maximum. Basically what we are doing here is return maximum. We are just returning the maximum path sum for the current node, right? We are considering only one of the subtrees, either left or right. So next step, here we will start the traversal from the root of the tree. That's what we will be giving here. So we have to start from traverse of the root, from the root basically, return the final maximum path of some result. So in our case, we have to return the result, nothing but RES we have given here, right? This one we are returning maximum path, nothing but we are returning the final maximum path sum result. So I'll just format the code. Let me hit the submit. So yeah, this works good, right? So what is the time complexity? The time complexity will be big of n. Why the time complexity is big of n? Because we are visiting each node exactly once during the traversal. We are visiting, again I'm telling, we are visiting each node exactly once during the traversal. So the time complexity would be big of n. What would be the space complexity? The space complexity would be big of h. We know that h is the height of the binary tree. Why the space of the, why the space complexity would be big of h? We are making use of the recursion stack, which can go as deep as the height of the tree. Hence, this one, the space complexity would be big O of h. So I'll just come here, that I'll just mention the time complexity big O of n, and the space complexity would be big O of h. Let me comment this one. So yeah, this is it. Thanks for watching, guys.